Okay, this is going to be a lesson on solving radical equations, okay? What you want to do first is you want to isolate your radical, okay? All right, so in this case, just want to get this away. That's all I have to do. I've isolated that, okay? Now, what you want to do is you want to get rid of the root, okay? All right, so if you have a square root, you square both, let me put it this way, let's just do it this way. All right, then what you want to do is get rid of the root of the radical. Get rid of the radical or exponent. I'll show you how to do the exponent in a little bit. Okay, so if we have a square root, we want to square it. Okay, if we want a cube root, we want to cube it. If we have a fourth root, we want to handle it to the fourth power. Okay, we'll talk about the exponents in a second. Okay, but I want to, in this case, I want to square both sides. Okay, then I add 3, divide by 2. Okay, now, once I got my answer, this is very important. If you have an even power radical, you have to check your answer, okay? No negatives inside, okay? So with odd power radicals, we don't have to worry about this. But with an even power radical, what I have to do is I have to check, because an even power can't have a negative underneath. Well, 2 times 14 is 28, minus 5 is 25. I'm good. So this is my answer, 14. Now, if that would have been negative, that part would be a no solution. Okay? Now, so on this one, I want to subtract 6. It's negative 4 divided by 4. That's going to be the cube root. The x minus 7, that's negative 1. I want to cube that. Negative 1 cubed is negative 1. Add 6. I get x equal, I'm sorry, add 7. Getting ahead of myself, sorry. Add 7. Get x equals 6. Now, I don't have to worry about this for odds, because if I put that back in, 6 minus 7 would be negative 1. But that's okay. With odd powers, you can have a negative on the inside. So that's going to be my solution. Okay, it's only for the odd powers. Now let's talk about what you do this one. All right, there's nothing here. I'm going to subtract 8. I got 32 equals x to the 5/3. Okay, now what you do, okay, in order to get this by itself, okay, what I'm going to do is I'm going to raise this to the 3/5. So what you want to do is raise by the reciprocal. All right? Somebody said, Mr. Evans, why would you do that? Now I want to do that on the other side too. Okay? Why would you do that? Because if I multiply, okay, if I multiply 5/3, sorry, if I multiply 5/3 times 3/5, I get x to the first, and that's what I want. Okay, all right. So this one, 32 to the 3/5, is going to be 8. Okay, now once again, I want to check. Now, what this means is that's a root of 3, so I'm good no matter what. Okay, but you got to be careful with that. Okay, all right. This, what I want to do, I want to square both sides to get rid of the square root. Now, what happens here is that's 4x plus 8. What do I do with that? That's really x plus 3 times x plus 3. So I'm going to need to do the box here. So that's x squared plus 3x plus 3x plus 9. So this is 4x equals x squared plus 6x plus 9. Now, this is a quadratic. Okay? All right? So what I want to do is I want to move these things back. So it's x squared plus 6x plus 9. Now, if I move the 4x over, negative 4x. Move the 8 over, negative 8. So that's x squared. This would combine to 2x. This combines to 1. Okay? I can do quadratic formula or factoring. That's really easy to factor. That's going to be x plus 1 times x plus 1. Okay? So the solution out of that would be negative 1. Okay? Now, here's something else you have to check. Okay? If I put that in to both sides, this is like when we did absolute value. All right, I put that in. The main thing is I got to watch for this. Okay? Well, 4 times negative 1 plus 8. Okay, that's good. Negative 1 plus 3 would be 2. I'm good there. So what I want to do is make sure that both parts are good. Okay? So this ends up being my answer. And what I mean by that is this. Let's say you had a problem. I'm just going to make something up. Let's say, I don't know if this is the solution, but this is just sort of the concept. Okay? Let's say I got an answer of 2 or something of that nature. Okay? All right? If I put that back in here, okay, let me give one that actually works. Let's think about this for a second. Let's do something like this. How do I get 2x there? Let's say I had 2x plus 10. Let's say it was something like this, okay? So for instance, I'm going to tell you right now, let's work this problem. Let's say the answer, I'm just going to say the answer here. Let's say the answer was, I don't know, negative 4, okay? The problem is, if I were to put that back in there, okay, 2 times negative 4 is negative 8 plus 10 is square root of 2. Fine. But if I were to put negative 4 into there, negative 4 minus 2 would be negative 6. It's impossible for a square root to be a negative. So that can't work. That would be bad. Okay, so this would be bad. So what you have to do is you have to make sure it works here, but you also have to make sure that it doesn't equal a negative number. Okay, all right, all right. So here's what I want you to try. I want you to try these. All right, now, I want to solve this. What I want to do is move this to the other side. So it just becomes positive. I want to square both sides. Subtract 2x. Subtract 2. All right, now, what I want to check is, let's make sure both of these work. All right, 2 times 5, 10, plus 7, good, plus good. All right, good. Both those are positive on the inside. Okay. This one, what I want to do, square both sides. Now, you have to square these front numbers too. So you have to apply that. So 2 squared is 4. Times, the square would get rid of that would be 3x. Square that as well. So 4 squared would be 16. That's going to be x plus 6. Distribute that, it's going to be 12x. Distribute that, that's 16x plus 6. Okay, if I solve this, I would subtract 12x. Okay, so I get 0 equals 4x plus 6. Subtract 6. Negative 6 equals 4x. Divide by 4, x equals, it's like negative 1.5. Now, the problem is, if I put negative 1.5 back in there, that would be a negative number. So this does end up not working. This is going to be a no solution. Okay, so you got to make sure that both your parts underneath work, and if you ever have an even power set equal to you can't have it ever set equal to a negative. All right, let's talk about how you do this one. You square this, square this. So I got this equals, okay, n over 6. Now, what I have to do is cross multiply that. So what ends up happening is I have to distribute that to both parts. That's 12n, 88 times 6, 528 equals 1n. Subtract 1n. I got 11n minus 528 equals 0. Add 528. I got 11n equals 528. Divide by 11. I don't know what 528 divided by 11 is. It is 48. Okay? Now, if I put that in there, let's just check. 48 goes in there, I'm good. 2 times 48 is 96, I'm good there. So that's gotta be your answer. Okay? All right? All right, this one, I want to square both sides. So it's 5v equals v squared. Now it's a quadratic, so I want to bring that back. So it's v squared minus 5v. Now the best way to solve this is factoring. I take out a GCF. Okay, so I set these equal to 0. Okay, so v equals 5. Now, I got to check that both works. Okay, 0's okay, 0's okay. 5's okay, 5's okay. Like, what would be bad, okay, all right, probably another example here would be something like this. This is probably a better example that I can show you. Let's say this was negative 4v on the inside, and this is v, okay? So squared and squared, that'd be negative 4v equals v squared. Okay, how would I solve that? Bring that back. Okay, I would take out a v here. V plus 4, v equals 0, then v equals negative 4. The problem is, okay, here was my original problem. Okay, now that negative 4 comes back in here, and on the surface that is 16, right, which would be okay. The problem is if I put that negative 4 in there, that can't work, so that wouldn't be my answer. The only answer I could have here would be 0. Okay, so I'm just going to go ahead, if that first example confused you, I'm just going to take that out real quick, all right, because that second example, all right, is a little easier to understand. So the idea is, the one thing you have to check for is not just the under part works, that if you have an even power, that it cannot equal a negative number. Okay, so go ahead and try these on your own, and that's solving radical equations.